Now we're going to focus on the scientific method. As you can see here, it's very important to understand that there is not going to be a set number of steps. There may be 8 steps, 7 steps, 6, 5, or even 4 steps. Now, the less amount of steps that we have, that's probably because we're combining steps. Another name for the scientific method you need to know is scientific inquiry. Inquiry referring to a question. The scientific method is an organized process of steps that scientists use to better understand the world around them. And the focus here is to better understand. That's why we're going to explore and experiment. The scientific method is a problem-solving tool. It's there to help you find a solution, an answer to the question. The first step that we're going to focus on is that we're going to start with a question. And having this question or this problem is usually based on observation or experience. And when we observe, a question will come about, or perhaps a problem will come about that we want to address or try and answer. Now, a good question can be examined, measured, and analyzed. Now, when we say examined, we're looking at how can we break it down, how can we look at the parts to it. And this is based off of observations, as we said, that created that question. Now, step 2, we're going to research. Now, we may want to go ahead and use different resources for that research. Now, some of the research that we could do is interview other people, or we can just go ahead and start with maybe the library, books, newspapers, magazines, even videos, or when I say valid, not Wikipedia, but real internet sites that have real information. Now, step 3, we want to form a hypothesis. Now, a hypothesis is basically an educated guess, but if we want to make it a little more scientific, we can basically describe it as a simple statement that tries to find an answer to the solution. It's not the answer, but it's what you think the answer may be. From what you have observed, you're able to come up with some sort of so-called solution that you think it's probably going to turn out this way. It describes the relationship between variables, and a variable means change. Different things that are going to be studied, different changes in this experiment. An example of a hypothesis could be the light bulb might be blown if the light bulb doesn't turn on. Okay, so when I turn on the light bulb doesn't turn on, it may be blown. Now, step 4 focuses on scientists creating an experiment. Now, specifically a controlled experiment. Now, when we talk about a controlled experiment, we're talking about there's only one variable that will be tested. And when scientists start this experiment and they prepare, they're going to write down a set of procedures or steps, okay, that will be used. Okay, so procedures would be these step 1, step 2, step 3 of what you're going to do in the experiment. And remember, when we deal with a controlled experiment, there's only one variable, only one change that we're going to talk about, and we'll explain what that means in just a little bit. So we're going to design an experiment in step 4. We're going to come up with it. I think in the lab that we talked about, we combined step 4 and step 5. So you come up, you design a controlled experiment, you come up with the procedures, and then step 5, we're going to test. We're going to do the experiment. And here we're going to actually follow the written procedures I made up in step 4. So I'm going to write it all out in step 4, what I think I'm going to plan on doing, and then in step 5, I'm actually going to follow this. So it requires a lot of thinking and planning. Now, during the experiment, we are dealing with 2 types of variables, an independent variable and a dependent variable. Now, the independent variable is what is changed or manipulated. This is going to be dealing with the experimental group. So The focus here in the experimental group will test that independent variable. So if I'm doing an experiment and I have multiple changes that I'm going to be looking at, that is referring to the experimental part or the independent variable. We're going to be talking about a little boy, Timmy, who wants to do a science fair experiment, and he wants to take some teeth that he got from the dentist, and he wants to test what liquids cause tooth decay. And basically, he's going to have one tooth that will not be any liquids. It'll just be by itself. Okay, and that will be what's called the control. It's left alone. Now, the other teeth that's not in the control, the other teeth, he's going to place them in different liquids. So one tooth he may place in water. Another tooth he may place in Coca-Cola or Pepsi. And a third tooth he may place in Diet Coke or Diet Pepsi. Another tooth he may put in lemon juice or milk. Maybe another one in orange juice. Okay, so you have one in like Pepsi, Diet Pepsi, water, orange juice, milk. So they're all in different liquids. So these different liquids are part of the experimental group, what we're doing in the experiment. Okay, and these different liquids represent the independent variable. What is being changed? So what is being changed? We're placing them in different liquids. So we have a control, which is the tooth by itself. It's not in anything. It's just being left alone. And then we have different liquids like water, milk, soda, diet soda, orange juice. And these represent the different changes, the different parts of the experiment, the independent variables. Now remember, the experimental group tests these independent variables. What am I changing? I'm changing the different liquids. So this is the experiment to see which one will cause more tooth decay. Will it be water, milk, soda, diet soda, orange juice, lemon juice? Okay, so the experimental group will test how much of the change affects the tooth. Now scientists will compare the results of the experimental groups to the control. So what was the control? Leaving the tooth alone, not put in any liquid. So the dependent variable, remember dependent means being impacted by, relying on. So this dependent variable responds to the independent variable. Okay, so we're going to do some review over this and go over these terms: independent, dependent, experimental, and control group. Okay, so the dependent variable is what is being impacted. Okay, it depends on these changes. Okay, so what's the dependent variable here? Okay, how much tooth decay the tooth will be impacted by the certain liquid. And then step 6, we're going to observe and record all the results. The focus here is recording the results. We're going to write down. And then we can go ahead and as we watch the experiment, we can record the data in a little tally chart. Then we can go ahead and create tables and charts and graphs. We did in class the bar graph. But it is very important to be honest and ethical, not to cheat, not to write down false information, but to be honest, okay, to do the right thing when you're taking these results. We don't want to falsify any results. And then when we're doing this, we can video or take pictures to show all the procedures and the results, that we actually have proof of what may be transpired. And then step 7, we're going to propose a conclusion. Now the conclusion communicates and reports all the results. We can share this with other people, and it basically closes the book. Did it answer my question? Was I correct? Was I not correct? Now if I was correct, this becomes a scientific law, especially if I can prove it. If it's not proven and I do the experiment a couple times and I have some sort of belief or explanation, but I'm getting different results, I'm not really proving it, this would become a theory. Okay, so a theory, I can go through the scientific method, I can get some results, but there's not a 100% positive end result. So if I do this experiment again and again, I don't have the same result every single time. Okay, so if I don't have that end result the same, it may become a theory. We think it should happen. It's a theory. The scientific law is a observed repeated pattern, okay, based on, as we said, repeated experimental results. Okay, so every time we test it, same result, same result, same result. That would be, and then become a law. Okay, here's the little example about Timmy. This is what we talked about just a little while ago about Timmy with his science fair experiment. He wants to test tooth decay, and he goes to the dentist and hockey players, and he gathers teeth, and he basically decides to test the teeth in different liquids, okay, that people drink. Okay, so when he comes up with this experiment and he plans for it, comes up with all the procedures, here's a question for you. Why did he not decide to test the teeth on solid foods and liquid foods? Yeah, that's right. He should only have one variable. In the first question here, why did he not decide to test the teeth on solid foods and liquid foods, both of these? It's because he should not be having more than one independent variable. So the focus here, the solid foods and the liquid foods both describe independent variables. They are changes that I'm doing to the teeth. The control was the tooth is by itself, but I need one type of change across the board, and we're going to focus on different liquids. Now the second question is, why did he not decide to test teeth, eggshells, plastic, and metal in these different liquids? Well, the answer here is number one, he wants to check tooth decay, right? So the focus here is, okay, he needs to focus on teeth, right? Eggshells can represent teeth or the material that teeth is made up of. But the focus is he shouldn't be putting teeth in some of the liquids and then eggshells in some of the liquids or plastic in some of the liquids. He has to have the same material across the board that he's putting in those different liquids. So he has to stick with, is it just eggshells? Is it just teeth? Now, Timmy places one tooth in a container with no liquid. We said that. That is the control. He places another tooth in water, Diet Pepsi, Pepsi, Mountain Dew, milk, and another one in orange juice. Those represent the experimental group. Okay? These are also the independent variables because these are the ones impacting the teeth. Okay? What's the dependent variable? Okay, the dependent variable is the tooth, the teeth being impacted. Okay? So every tooth that I put in those different experimental group liquids, that will be the dependent variable. Okay, let's take a look at the answers. Now let's apply the scientific method to real life. And I'm going to give you some practice problems. But in order to do that, let's focus on three parts that some students have trouble with. What is a hypothesis? What is the dependent and independent variables? So let's take a look. Again, a hypothesis is a proposed answer to the problem. It's the educated guess. What do you think will happen in relationship between the different variables, the dependent and independent variable being studied? And remember, during the experiment, the independent variable is changed. That's the liquids from the teeth experiment. I'm changing, okay, just liquids. And I'm going to observe the effect on the dependent variable. How is the tooth being impacted or affected? So the dependent variable is what is being impacted. What is the dependent variable depends on the independent variable. This depends on the other variable being changed. Okay, so here we have battery strength. The problem is, my question, Does the brand name of battery affect how long the battery lasts? So I want you to give me the independent variable, dependent, and your hypothesis. So let's look at the problem, the question again. Does the brand name of the battery impact how long the battery lasts? Now the independent variable is what's going to be changed. Now remember, I only need one type of variable. I can only have one type of variable. So I'm only going to be focusing on batteries. I'm only focusing on batteries here. I'm going to have one battery by itself, normal. That's the control. But then the independent variable, what am I changing here? What's the focus of the question? The brand of battery. So the independent variable, what I'm going to change are all different brands of battery. So I might have Energizer, I might have Duracell, I might have Rayovac, I might have another cheap kind. So that's the independent variable. I'm changing the brand. Now the dependent, what's being impacted is the battery life, how long it lasts. Okay? And what would be my hypothesis? What am I guessing? The more expensive battery, or maybe the brand name of battery that's more expensive, will last the longest. Okay, so let's take a look at the answers. So the independent variable is what I'm changing. This is part of the experimental group. I'm looking at the different battery brands. The dependent variable, okay, what is being impacted, how long it's going to last. And then the hypothesis, a more expensive or more popular brand will last or result in a longer lasting battery. So let's go ahead and let's do some more. Does temperature, how hot or cold, affect how quickly sugar dissolves in water? That's your question, that's your problem. The independent variable, remember, this is the experimental group. What am I changing? I am changing the temperature of water, right? So basically I'm going to have different temperatures of water, and then what I'm going to do is go ahead and look at the dependent variable. What's going to happen? How quickly it will dissolve. How quickly the sugar will dissolve. That's the dependent variable. Okay, what is being impacted? Now remember, I'm not using sugar, salt, chalk. I'm not using different substances. I'm just using sugar. Only one variable here. Okay, so the independent is the different temperatures. The dependent is going to be how quickly it dissolves. So my hypothesis would be the hotter the temperature will result in the sugar dissolving quicker. Now, what if my hypothesis was the colder the water is, the faster the sugar dissolves? Well, that would be a wrong hypothesis. The experiment would prove it wrong. But that's okay if I have a wrong hypothesis. When I'm done and I get my conclusion, I would have to go back and change it. So some of our educated guesses could be wrong. Okay, here's another one. Plant growth. The problem is the color of light going to be related to plant growth? So what's the independent variable? If I do an experiment, what are the different changes? What do you think? Yeah, the color of light. So I'm going to have different colors of light on different plants. And I'm going to see which color. I might have blue light, orange light, yellow light, red light, green light. Now, these different color lights, I'm going to observe them. And remember, I'm just dealing with light colors. I'm just dealing with the same type of plant. The dependent variable is how fast the plant will grow. Okay, will a plant grow faster with certain lights? And then my hypothesis would be orange or red light. Orange light will cause the plant to grow faster.